Hi, in this video, I'm going to introduce a very useful shortcut that will help you solve problems very quickly. This turns out to be super useful, not just for the board exams, but also for competitive exams like the IIT JEE. My name is Balaji Sampath, and I have helped thousands of students top their board exams and also crack entrance exams like the IIT JEE as well as NEET. And we are now going to learn about this technique called Componendo and Dividendo. In some schools, they actually teach this as part of the school itself. But in many schools, they don't introduce this idea, but this idea turns out to be very useful. And I'm going to show you how you can learn this technique and use it for solving many different types of problems. Okay, so let us get started. Componendo and Dividendo. Okay, if two ratios are equal to each other, so the first ratio, I'm going to write it as numerator by denominator using capital letters. So n by d, capital N by capital D is equal to n by d but using small letters. So small n by small d. So this ratio is equal to that ratio. Okay. Then you can combine n and d on the left side and you can combine n and d on the right side, and you will see that that statement will also be valid. For example, n plus d by n minus d, right? Capital N plus capital D by capital N minus capital D is equal to small n plus small d by small n minus small d. Usually people write this as a by b equal to c by d, but then it's hard to remember. That's why I have written everything in terms of n and d. N stands for numerator, d stands for denominator, and small n and small d basically numerator and denominator on the right side. So what can you say here? Whatever you are doing with the numerator and denominator on the left, you are doing the same with the numerator and denominator on the right. By the way, instead of saying I will add and there in the top and subtract in the bottom, you could have done it in the reverse. You could have said n minus d by n plus d is equal to small n minus small d by small n plus small d, right? Basically, we will focus on this because that one is just the reciprocal of this. So we don't need to worry about that. So basically, let's focus on this, right? How do I prove this? Very easy to prove. So let me start with the left-hand side. So left-hand side is n plus d by n minus d. So let us divide this top by capital D, and then we should also divide the bottom by capital D. So I can divide both by capital D, and so what is going to happen? I'll get n by d plus, what is d by d? 1. So I'll get n by d plus 1 divided by n by d minus 1. And what about the right hand side? Right hand side, I'm going to start with this, and if I now divide the top by small d and the bottom by small d, then I'm going to get small n by small d plus 1, right? That will be the top, and small n by small d minus 1, right? D by d is going to give you 1. So if you now compare these two, you have capital N by capital D here, and you have small n by small d here. But they are both equal. They are both equal. So that means this is equal to this, plus 1 same, and then denominator here you have n by d, capital N by d, and here you have small n by d, right? So again you see that these two are equal. So actually what we have arrived at there and here, they are both the same. They are both equal. Why? Because capital N by capital D is equal to small n by small d. So this is equal to this. So if these ratios are equal, then that means this must be equal to this. So we have proved that the left hand side and the right hand side, they are equal. So therefore we have proved this statement. Proof is very easy. Proof is very easy. The important thing is remembering this statement and using it in different situations. And not just this alone. Right? Here I have written n plus d by n minus d is n plus d by n minus d, but you don't need to do that. You can also show n plus d by d is equal to small n plus small d by d. That's very easy. If I add 1 on this side and add 1 on that side, then I'll get this relationship. But basically what am I doing? I'm combining numerator and denominator, okay, at the top, and here I'm doing just the denominator, right? So exactly what you do here on the left side with capital N and capital D, you must do the same on the right side with small n and small d. Another thing that you can show is capital N by n minus d is small n by small n minus small d. Similarly, capital N by n plus d is small n by small n plus d. Basically, you can keep writing lots of relationships like this. The point is not to remember each of these. The point is to be able to use it. But first I have to remember. Well, you can remember it in a very simple way. Whatever you do with the numerator and denominator on the left side, when I say whatever, I mean by adding or subtracting, right? You can add, you can subtract. Okay, you can put it in the denominator, you can put it in the numerator, doesn't matter. Whatever you do on the left side with capital N and capital D, you should do the same thing on the right side with small n and small d. That's all. Here, I'm doing capital N plus capital D divided by capital N minus capital D, and therefore I should do the same thing with the small n and small d. So small n plus small d by small n minus small d. You can do the same kind of thing differently if you want. You can say, hey, I want to do n plus d by d minus n. No problem. Well, if you did this, then you must do small n plus small d by, since I put d minus n, I must now do small d minus small n, right? This statement is also going to be true. So we can come up with our own statements, but the main idea is whatever combination you're doing of n and d, right, there at the top and at the bottom, do the same thing on the right side as well. That's all. So, okay, so now we can figure out how to write these things, but why are we learning this? Because it turns out to be super useful, and the best way to learn how to use this is by looking at examples. Let us now see how we can use Componendo Dividendo to very easily solve a question that looks like this, right? Here we have root of x plus 1 minus root of x minus 1 divided by root of x plus 1 plus root of x minus 1 is equal to 2 by 3. The usual way of solving this is to cross multiply, try and bring things together and then simplify and so on. It's a little bit longer, but if you now actually look at this, if I add the numerator and denominator, well, what is going to happen? This will cancel, right? This is minus root of x minus 1, this is plus root of x minus 1, it will cancel. So when you add the numerator and denominator, you will only get 2 times root of x plus 1. And when you subtract, and it's a good idea to subtract denominator minus numerator, because you see this has both plus and that has minus. So if I did d minus n, then what is going to happen? This minus this will go, this minus minus that, right? So it will become 2 times root of x minus 1. So we should be adding the numerator and denominator, and we should be doing d minus n. Maybe we can write d plus n by d minus n, right? So d plus n by d minus n, well, whatever you do on the left side, you must also do on the right side. Okay, why am I doing this on the left side? Because then the whole thing will simplify. So let us see. So let me do d plus n. So this plus this, d plus n by d minus n. So when I do minus of this, what will I get? Minus of root of x plus 1, minus of minus will become plus root of x plus x minus 1. And I must do the same on the right side. So d plus n. So 3 plus 2 divided by 3 minus 2. 3 minus 2. Okay. Now how is this useful? Let's see. You've got plus root of x minus 1 minus root of x minus 1. That will cancel. Right. So it will become 2 times root of x plus 1. And here root of x plus 1 minus root of x plus 1 will cancel. So you will end up with 2 times root of x minus 1. So you're going to get 2 times root of x plus 1 by 2 times root of x minus 1 is equal to 3 plus 2 by 3 minus 2. 3 plus 2 is 5, 5 by 1. Okay. Now the 2 and 2 can be cancelled. And so if I now squared both sides, right? Suppose I now squared this and squared that, I'm going to get the root going away. So you'll get x plus 1 by x minus 1 is 5 squared, 25 by 1. Right? So x plus 1 by x minus 1 is 25 by 1. But I need to find x. Well, you can cross multiply if you want to. But wait a minute. Again, you can use Componendo Dividendo. Because if I add, minus 1 plus 1 will cancel. You'll end up with 2x. And if I do this minus this, right? Numerator minus denominator, then what is going to happen? X will cancel and you will get 1 minus minus 1, which is 2. So let us write numerator plus denominator by numerator minus denominator. That's what I'm going to do, because that will basically pull out the x. So suppose I do that, remember you must do the same on the right side also. Whatever you do on the left. Here I did d plus n by d minus n. Here I'm doing n plus d by n minus d. Whatever I do on the left side, I must do on the right side. So if I did that, what is going to happen? X plus 1 plus x minus 1 by x plus 1 minus of x minus 1. Minus x plus 1, right? Minus of x minus 1 is minus x plus 1. And I must do the same here. So 25 plus 1 by 25 minus 1. Okay, so now minus 1 here and plus 1 will cancel. Minus x and plus x will cancel. So 2x by 2, and what is this? 26 by 24. 2x by 2 is equal to 26 by 24. So let's cancel this out. And so if I cancel a factor 2, this is going to be 13, and this is going to be 12. And so x is equal to 13 by 12, right? 2 times we just applied Componendo Dividendo, and therefore we are able to then simplify and solve this problem. Okay, otherwise cross multiplying, simplifying, all that would have been very messy, whereas Componendo Dividendo makes it very clean and simple. In the board exams, they often give you questions that look like this, where they give you the value of an expression and ask you to find the value of cot theta, tan theta, cos theta, and so on. Okay, let us now look at this question, and we will see how we can use Componendo Dividendo to solve these kinds of problems very quickly. Okay, so if secant theta minus cosecant theta by secant theta plus cosecant theta is 4 by 7, then find the value of cot theta. Now notice, if I add these two, add the numerator and denominator, then minus cosecant theta plus cosecant theta will cancel. You'll only be left with 2 times secant theta. And if I do denominator minus numerator, then what is going to happen? Secant theta will cancel and you'll get 2 times cosecant theta. So denominator plus numerator divided by denominator minus numerator. Well, whatever you do on the left side, you must do the same thing with the numerator and denominator on the right side. So you must do d plus n by d minus n using the small d small n. So what does that mean here? Well, secant theta plus cosecant theta plus secant theta minus cosecant theta divided by secant theta plus cosecant theta minus of the numerator, minus secant theta, minus of minus will give you plus cosecant theta. And on the right side, what will happen? Well, 7 plus 4, you should do the exact same thing, right? So 7 plus 4 by 7 minus 4, right? Denominator plus numerator by denominator minus numerator. So if I now look at this, minus cosecant theta plus cosecant theta cancels out, secant theta minus secant theta cancels out, and so you're going to get 2 secant theta by 2 cosecant theta. 2 secant theta by 2 cosecant theta, and what is that? That is 7 plus 4, 11, 7 minus 4, 3, so 11 by 3. And so I can now cancel out the 2. Secant theta is 1 by cos theta. Secant theta is 1 by cos theta. Cosecant theta is 1 by sin theta. So 1 by cosecant theta will be sin theta. So I can just substitute that here. I can write 1 by cos theta for secant theta into 1 by cosecant is sin. So therefore sin theta. Now what is this? This must be 11 by 3. So this is tan theta. Tan theta equal to 11 by 3. But if tan theta is 11 by 3, the question is asking you for cot theta. Cot theta will be the reciprocal of tan theta. So it will be 3 by 11. It will be 3 by 11. Cot theta is equal to 3 by 11. The previous examples were all very simple. Actually, you could have also solved it by cross multiplying. But now look at this question. So here we have x cube plus 3x divided by 3x square plus 1 is equal to 341 by 91. We want to solve for x. Well, if I try cross multiplying, I can simplify and solve it, but it won't be so easy. It will actually be quite difficult. On the other hand, if you look at this, x cube, 3x, 3x square, 1, think about where do these terms come up? Well, if you remember a plus b whole cube formula, you get a cube plus 3a square b plus 3ab square plus b cube. 3, you see, it seems to be very similar to this, except b must be 1 and a must be x, right? So suppose I try x plus 1 whole cube, what will you get? X cube plus 3x square plus 3x plus 1. These are actually the terms sitting there, except they are not in order, right? You have x cube, 3x, x cube, 3x, and the denominator has 3x square plus 1. So actually, if I did numerator plus denominator, that will be x plus 1 whole cube, x plus 1 whole cube. Okay. But then x plus 1 whole cube, when I add these two up, it will be easy. But then the denominator still has 3x square plus 1. What do I do then? Now let's think about what will happen if I did numerator minus denominator. Okay, so numerator plus denominator is going to give me x plus 1 whole cube. What will happen if I have numerator minus denominator? Well, then you will get x cube minus 3x square plus 3x minus 1, right? Alternate terms will have negative. That is a minus b whole cube formula. You can do that. Or you can say, let's make a as x and b as minus 1. If I make b as minus 1, this will have a minus term. Because it's minus 1 whole square, this will be still plus, and minus 1 cube will be minus 1, right? So if I try to put b as minus 1, x minus 1 whole cube, well, you should remember the expansion directly. But if you don't, you just simply substitute b equal to minus 1, a equal to x, you're going to get x cube, okay, 3x square into minus 1, so minus 3x square, and then 3x into minus 1 whole square, which is going to be just 1, right? So therefore 3x and minus 1 whole cube, which is minus 1. Now notice, this and this, these two come in the denominator, so it's actually numerator minus denominator. So very good. So then if I did numerator plus denominator, I get a nice expression. Numerator minus denominator is also a nice expression, and therefore clearly you must use componendo dividendo here. So numerator plus denominator by numerator minus denominator on the left side must be equal to numerator plus denominator by numerator minus denominator on the right side. So say it like that. Okay, say it like that, then you will remember it very easily. Okay, so let us do numerator plus denominator, okay, on the left side, right? And here numerator minus denominator must be whatever I do on the left, I should do on the right. So basically 341 plus 91 by 341 minus 91. Now what is this? X cube plus 3x square plus 3x plus 1, well, that is x plus 1 whole cube. X cube minus 3x square plus 3x minus 1, x minus 1 whole cube. So x plus 1 whole cube by x minus 1 whole cube is equal to the sum of these two, which is 432 divided by this minus this, which is 250. Now if I try to factor out a 2, this is going to be 125. 125 into 2 is 250. If I factor out a 2, so basically I'm going to get 216, right? 32 will be giving me 16, right? So 216. 216 by 125, 216 by 125. Now this is a cube, right? This is a nice cube, x plus 1 by x minus 1 whole cube. You can think of this as x plus 1 by x minus 1 whole cube. So this also should try to write it as cube. 125 you know is 5 cube. What about 216? 6 cube. So this is 6 cube by 5 cube. So 6 by 5 whole cube. So if I just take the cube roots on both sides, I'm going to get x plus 1 by x minus 1 is 6 by 5. Now you can solve. Just by cross multiplying you can solve. But since we use componendo dividendo so far, why not use it again? So if I used it again, basically if I add, the plus 1 minus 1 will cancel, you will get 2x. And if I subtract numerator minus denominator, x will cancel and you will get 1 plus 1, 2, right? So let us apply the same thing again. So what am I going to get? X plus 1 plus x minus 1, right? Numerator plus denominator by numerator minus denominator. X plus 1 minus of this. Minus of x minus 1 is minus x plus 1. And you should do the same on the right side. So 6 plus 5 by 6 minus 5. And so this, I'll cancel the 1 and minus 1. Here I'll cancel the minus x and x. So 2x by 2, and this is going to give me 6 plus 5, 11 by 6 minus 5 is 1. So 2x by 2 is 11 by 1. Cancel this out. So x is equal to 11. X is equal to 11. Notice this question we have solved it in one step of componendo dividendo simplifying and one more step of componendo dividendo. That's it straight away, right? Now if you try to cross multiply and then factorize and solve, it would have been extremely difficult, Okay, the question itself is given in such a form that basically if you should think about whether if I add it, it will simplify. And if I subtract, will it simplify? And yes, it will. And that's why you use componendo dividendo to solve a question like this. I hope you understood how to apply componendo dividendo to solve many different types of equations. So let us quickly summarize what we have learnt. If you have two ratios that are equal, capital N by capital D, capital N is basically the numerator, capital D is the denominator. If it is equal to another ratio, small n by small d, then any combination of the numerator and denominator here on the left side is equal to the same combination on the right side. So for example, n plus d by n minus d is equal to n plus d by n minus d. You can also say d plus n by d minus n is d plus n by d minus n. Whatever you're doing on the left side, you should do the exact same thing on the right side. Okay. Similarly, you can also write n plus d by d is n plus d by d, or n by n minus d is n by n minus d. Basically, whatever you're doing with the numerator and denominator on the left side, do the exact same thing on the right side as well. Okay, so you can add or subtract. When I say whatever it means you can add or subtract the numerator or denominator, and you can do the same for the top as well as at the bottom. And whatever you do there, do the exact same thing with the small n and small d on the right side. It turns out that this is very, very useful in solving many problems very quickly. So if you like this video, please do subscribe to the AHA Guru YouTube channel, and you will then be able to get lots of similar tips and techniques that will be very useful for your exams.